Hey, welcome back to this bootcamp series. In this video, we're going to learn how to set up our own basic API. So in our previous video, we already learned the very basics of Express, but in this video, we're going to learn how to make our endpoints flexible, right? So how to have maybe a parameter or a variable in the URL. We're also going to learn how to not only send out JSON, but how to receive incoming JSON. Also, we'll learn about something in the browser called CORS, and we'll learn how to work around this so that our API can be available from any domain on the web if that's what we want. Finally, towards the end of this video, we're going to put all of the puzzle pieces together. So we're going to see a few examples of how the front end can connect to our back end. In other words, we'll see how you can use front-end JavaScript to handle routing on the client side. This is often referred to as a single-page application, or the SPA acronym. Anyways, we're going to cover a lot of ground in this video, and it might seem like a lot of different topics and like we're jumping all over the place, but I promise there is a method to this madness, and all of these topics really intermingle and work together. So by the end of this video, I hope the big picture starts to come into focus. Anyways, without further ado, let's jump into the action. Okay, so in the previous video of this series, we learned how to use Express to create a basic web server. And we also learned how to use a template engine to generate HTML on the server side within Express. Now that's great, but in the modern era of web development, there are many situations where we would instead want to generate the HTML on the front end with client-side JavaScript. And in that case, the server just needs to instead send over raw JSON data, and the client-side JavaScript can take care of the rest. Right? And we've already seen this in action earlier in this video series. Remember the dog API lesson where we wrote front-end JavaScript to fetch data from this dog API? Remember, if you look at this URL, this would retrieve raw JSON data for just corgi dogs. Or this URL would retrieve the raw JSON data for beagle dogs. Now, we've already learned how to consume or leverage or load existing data like this from someone else's API, but in this video, let's learn how to create our own API like this ourselves. So we're going to have two main goals. Number one is to learn how to have sort of flexible URLs or routes like this, right? Where this highlighted section is sort of a parameter or a variable, and then we can do different things on the server side and send different data back. So goal number one is to have flexible URLs or endpoints. Goal number two will be to learn how to work with JSON data. What I mean is not only sending JSON from within Express, but also being able to receive and work with incoming JSON data. But let's not get ahead of ourselves. Let's take this one step at a time. So let's jump into VS Code. If this basic Express boilerplate code doesn't make sense to you, that's okay. You'll just want to go back and watch the previous video in this series on my channel. But basically, we're setting up a route for just the / or the root of our domain, and it's just going to say hello world. So if in a new tab I visit localhost 3000, we see that hello world. However, let's imagine we want to add a new route right now where you can say /animal/ and then the name of a different animal. So you could say meows a lot or barks a lot, right? And we would want to do different things depending on whatever this final segment of the URL is. So to make that happen, we would just set up a new route. So app.get, and we could say /animal/ and then this is where we would want it to be dynamic, right? This could be any value here. So in order to turn this into a parameter or sort of a variable or wildcard, we just say colon, and now we can make up any name we want. Why don't we just call it name, right? The name of the animal, but this could literally be anything. Okay, so let's go with name. Now let's also say comma and give this a function. So request response, arrow symbol, curly brackets. Okay, now really the whole point of this example is I just want to show you how you can access this value from within this function. So we just start working with the request object, request dot, and then it's params. So Express will add a params object onto the request object for us, and then you can look inside it for whatever you named your different parameters in the URL. So we named ours name. But you could have multiple of these in your URL pattern. So you could have another one, right? And then you could access that with request params pizza. So it's up to you, however flexible you want your URLs to be. But just to see that this works, maybe I could console.log request.params.name. Get rid of that pizza here. Cool, and then just maybe response.send thank you. Let me restart the server really quick. So now if I visit /animal/meowsalot, in the console of where we're running Node, we see that value. So we were successfully able to pull in that URL parameter. Now you could imagine you can use that value to maybe look up data in a database or make an API request of your own, right? Do something dynamic. But the point is once you have that value in a simple string with JavaScript, it's up to you to make something actually interesting happen. So just for a super quick example, I won't bore you by typing this out, but let me copy and paste a bit of example or reference code. Okay, so I'll actually go ahead and get rid of this example route and just paste in this code. If you're wondering where this copy and paste code just came from, you can find a link in the description of this video to a GitHub repo, and it's going to have all 3 example projects that we're going to walk through together in this video. So this would just be the folder that starts with the name of 01. Just really quick, you can find it on GitHub, right? It's just github.com/learnwebcode, YouTube, backend, frontend. So right now I'm just copying and pasting a little bit of example code from this 01 API basics folder. But essentially, it's just going to look for /API/animal/name, and then it's going to actually do something depending on that value. So I've hard coded. In the real world, this would actually be pulling dynamically from a database, right? You wouldn't be manually setting up different if statements, but I've set up examples for meowsalot, barksalot, and pursloud. So back in the browser, actually, let me restart this. If you don't want to have to manually restart it, remember you can use npx nodemon and then the name of your file, and then it will automatically restart for you every time you save a change. Okay, but now in the URL, if I say /API/animal meowsalot, it gives me that raw JSON data with the name, species, the URL to a photograph, a JPEG. I can do the same thing for barksalot, and pursloud as well. You get the idea. So really all I wanted to showcase here is just how to have a parameter in your URL or route pattern. Okay, moving on, I now want to show you how to use a query string in your URL. Let me copy and paste an example. Again, this is from that same reference code. Okay, so this sets up a route. If you make a GET request to /fake search, let me show you how this works. And I'm going to leave my console open because we're logging the results so you can see how this works. So if in the address bar I go to /fake search, and now this is the interesting part. Sometimes with a URL, you want a recreatable URL. For example, like a search results screen. So if I say sky equals blue and grass equals green and maybe search term equals dog. Push enter, thank you for your request. But notice in the console in VS Code, we're logging request.query. So Express takes all of those query strings, those parameters in the URL when you use this syntax of question mark and then key equals value. And then you can string together with the and symbol, right? And this equals this, and this equals this. So Express automatically adds that onto the request object inside of query, and then it is an object with as many different properties as there were in the URL, right? So we just get a JavaScript object with key pair values. Cool, so you can use your imagination and imagine how you could use those values to look up data in a database or make other API requests or do anything you need to do. Okay, so far we've seen 2 examples of GET requests. Now let's change gears and talk about a POST request. So for example, let me paste in a little bit of example code. Again, this is from that same GitHub repo folder. So imagine someone sends a POST request to /API/secret, and then I'm checking to make sure that they sent along a bit of data where the username equals John Doe and their password equals the super secure QWERTY. But only if that's the case, then I'm going to send them back this super top secret data. Otherwise, I'm going to say that's incorrect. Now, the whole point of this example is I want to show you how to work with incoming JSON data. Right? It's very easy in Express to send JSON data back as your response to the client. Right? We just say response.json, but how can we parse or work with incoming JSON data, right? If we expect our user to send over an object with property of username and a property of password, how can we receive that? Now, believe it or not, but by default, Express is not configured to easily parse JSON like this for us. In my opinion, I think they should just enable it out of the box. That's just my opinion. So to enable it, we just go up towards the very top of our file and we just call a piece of middleware. So we want to use this globally for our entire application for all routes. I guess you don't need to use it globally. It's up to you, but let's just say app.use, and we don't need to install a package. It's built into the core of Express. We just need to enable it. So we just say express dot, and then we call its JSON method, and that's it. Now Express will be able to easily receive and parse incoming JSON data, and it will automatically add it onto the request object, onto the body object for us. Cool, so now we can successfully access it just like this. However, now the question becomes, how can we test this out? So you could write a bit of client-side JavaScript for the web browser to asynchronously send a post request. However, when you're just setting up the basics of an API, that can be a lot of extra work, right? Maybe you don't want to have to program your front end or client side code right away. So instead, you really want to have a tool on your computer called Postman. So you can just visit postman.com. I believe they changed their website recently, so they really don't show a download link on the homepage. But if you just visit /downloads, then you can easily find the download link, right? So download the app. It's completely free to use. Now, the very first time you open the app after you download and install it, it'll likely look like it's asking you to log in, but you don't need to. You don't need to sign up for an account or log in whatsoever. Usually towards the bottom corner of that welcome screen, there's a skip button or a use logged out button. It might be really small and hard to find, but it's usually somewhere in the bottom corner. Anyways, you'll eventually see a screen like this in Postman. And what in the world is Postman? So it's just a tool that lets us send or test different HTTP requests. So instead of us having to program client-side JavaScript in the browser to test out, right, sending a post request to this URL with this data, instead we can just use Postman to sort of mock up this request. So let's click this icon here to sort of set up a new request. Let's change the type of request to a post request instead of a GET request. Right, that's when you want to send data. And for the address, let's say http://localhost 3000/API/secret. Right, that's the URL pattern I've set up here. Now, we are expecting the user to send over an object that's JSON, where the username is John Doe and the password is QWERTY. So let's set that up. Let's actually get it wrong on purpose first. But first, let's go into headers here in Postman. And let's just set the key to content type. If you just start to type it in at all, it'll suggest. So we want content type. And the value is, if you just search for JSON, we want application/JSON. So this is just our way of describing the type of request we're making to the server. From here, now we can click on body. And then let's click this raw option. And now in this area, you can just type out a bit of JSON. So let's have a JavaScript object. Let's have a property of name and set it to John Doe, comma, and then let's get the password wrong on purpose. So password, just nonsense. Oh, you can see it's underlining password. It wants this to be valid JSON, so you can wrap it around in quotes, and then you can just click send. Cool, so the server's response, our Express server says that is incorrect, but if I change the password to QWERTY and send the request again, whoops, it still says that is incorrect. This property should be username instead of just name. Click send. Cool. So you have secret access for us to tell you that 2 plus 2 is 4. Cool. So that's just a quick example of not only how you can receive or parse or work with incoming JSON data that visitors send to you, but it's also an example of how the Postman app can make it really easy to test your API, your endpoints. The real reason Postman is nice is because oftentimes when you're creating an API like this, it really doesn't matter what the client-side solution is, right? You could have a native Android app connect to this API. You could have a native iOS app. You could have a web application. It doesn't matter. Just about any device and environment can make HTTP requests. So if you're tasked at your job to create an API, you don't even need to worry about the client side. You can just use Postman to test it out. Okay, and then a quick side note. In addition to sending a GET request and a POST request, you can also send a PUT or DELETE request. You can see there are all types of other requests, but I would say those are the big common 4. GET, POST, PUT, and DELETE. We've already talked about GET and POST. PUT is usually used when you want to update an existing item on a server somewhere, and DELETE is self-explanatory, right? When you want to delete something. We're not going to go over it in detail, but in Express, let me paste this in, just like how you would work with a GET request or a POST request, you can call these conveniently named methods of delete and put. Okay, and they work exactly the same as the GET and POST methods. You specify a URL pattern and then you give it a function. Cool. Now at this point, I want to change gears and talk about how we can access our API from anywhere on the web. Because actually at the moment, we can't. So what I mean is, if we visit localhost 3000 API animal meows a lot, yes, we can view that in the browser. However, if I try to load this same exact URL on the fly with client-side JavaScript on a different domain, so for example in this tab, I've set up a code pen, and you can see I'm just trying to perform a basic fetch request to that exact same URL. And then if I view the console down in the preview area, access to fetch at that URL has been blocked by CORS policy. So for the next minute or two, let's talk about what in the world CORS is, because we can see that it's blocking us from making an asynchronous request to a different domain. Essentially, for our own security, web browsers by default only allow you to make asynchronous requests with JavaScript, client-side JavaScript. They only allow that if it's being made to the same domain you're currently viewing, or right, that JavaScript originated from. So since I'm on the CodePen domain and website, and that's where this client-side JavaScript is originating from, by default, I would only be allowed to make requests to that same CodePen domain. Now, to get around this problem, we just need to adjust our server and API to send over a bit of data in the headers saying, it's okay, you can relax a little bit, browser. You can allow anyone to make requests, right, coming from any domain in the world to our API. So first, I want to show you how we can do that, and then I want to talk a little bit about when you would want to be very careful before you do this. So first, back in VS Code, if we want to tell the browser to relax and that you should be able to access this API from any domain, well, let's just go ahead and install a package. So npm install, the name of the package is CORS. I forgot to mention the CORS policy stands for Cross-Origin Resource Sharing. Anyways, the popular package name is just CORS. Let's go ahead and install that. Okay, then I'm going to start my server back up, npx nodemon index.js. Now let me show you how we use CORS. So up at the very top here, we would import or require it. Okay, and then we can just use it as a piece of middleware. So if you only want to make a few of your routes in particular available from any domain, you could just list that as a middleware function right about here. Or if you want to apply it globally, like we've already done here with JSON, you could just do that. You could say app.use and then just call CORS. Okay, just like this. Now if I save this and then back in CodePen, if I make a minor change just to trigger it to reload, and now check the console, cool, you can see the request was successful. Here's that JSON data. about the meows a lot animal. Okay, now let's talk a little bit about when you would want to be very careful before enabling this type of feature. So first of all, just to put your mind at ease, if your API is just serving up innocent, publicly available data, you don't need to worry, and you can always just go ahead and enable CORS if you want the whole web to be able to use your data. However, if, for example, we were building a bank website, we would want to be very careful. And the best example that I've seen explained is on this Stack Overflow answer. So essentially, imagine we have yourbank.com and then api.yourbank.com, right? And that would probably just receive and send raw JSON. The bank.com is the actual user experience website that you click on. And then the third website is badguy.com. So imagine you log in to yourbank.com, it authenticates you with a user account, and it gives your browser a cookie. Now, we have not learned about cookies in this bootcamp series so far. So for now, just know that the cookie is what lets the server trust or believe that you are who you say you are. Okay, and every time you make a request to yourbank.com, your browser automatically sends that cookie data to the server, and so the server can say, aha, you're this person, we trust that you really are that person. Anyways, imagine your bank website that you log into, imagine it wants to make honest, legitimate, asynchronous requests to api.yourbank.com. Well, by default, the web browser blocks that type of request, right? Like we just saw that in the CodePen example. So you would need to adjust the CORS policy of api.yourbank.com, if you were the developer of that site, to say, hey, you should actually allow requests from other domains. Or actually, to be more specific, you wouldn't just allow requests from any and all domains. You can configure this CORS package to only allow requests from one other separate different domain. So that's what they would do in the case of this bank example. They would not allow requests from the whole World Wide Web. They would just specify the bank.com website as the one site that's allowed to make these requests. Because if they didn't do that, and they did allow requests globally from any domain, then imagine if a user that was logged into their bank website went to badguy.com. Well, then JavaScript from badguy.com could make requests to api.yourbank, and your browser would automatically send that cookie to that API bank, and it would look like you were logged in, and so the requests could go through. Now, in the real world, this malicious attempt probably would not go through anyways, even if CORS was misconfigured, because any large website is using CSRF, Cross-Site Request Forgery Protection. But right now, we're getting into a huge tangent that really doesn't have anything to do with the topic of this video. We can talk more about how to be careful with cookies in a future video in this series when we learn about user authentication, so on and so forth. For now, really all you need to know is that CORS protection is enabled by default, and in order to relax that policy, we can just apply this header on our server or API. When you learn more about cookies and authentication, you will want to circle back to the topic of CORS and sort of connect the dots. Okay, now before we fully change gears and talk about something else, there is one thing I want to mention in regards to CORS, and that is that it's just a suggestion to the browser. The browser doesn't have to listen to your CORS suggestion. So please don't ever try to use CORS to actually secure or lock away your data. A malicious user could absolutely reprogram their browser to just ignore CORS policy, right? For example, that's really what the Postman app is doing, right? Postman does not care about CORS policy whatsoever, right? You can make requests to any domain you want from within Postman, and you're never ever going to run into a CORS policy error. So really, CORS is just a behavior in the browser itself designed to protect users. And that's all that it is. So don't ever think that your data is safe or locked down and no other domains can access it, right? Someone could very easily modify their browser to access it cross-domain. They could use something like Postman, or they could make a request on their back end, right? With something like Node or PHP. Anything on the server side that's running outside the context of a browser can absolutely access your data from a different domain. Anyways, the reason I'm spending a lot of time on CORS is because it's one of the most common topics I see that really gets people confused. Hopefully it makes a little bit of sense at this point, but we are now going to move on. At this point, for the final topic in this video, I want to talk a little bit about how the front end and back end can connect and really work together. Because in earlier videos in this series, we wrote a lot of front-end JavaScript, and now for the last 2 lessons, we've been looking at server-side JavaScript. But now the question is, how do the two really work together? And/or the question is essentially, well, how do we make use of all this API data? How do we leverage it, or why is this so useful? Remember earlier I said that you can access your API from any device, right? A native iOS or Android app or a web app. And obviously this course, this bootcamp series, is focused on web apps and web development. So right now I want to spend just a few minutes to explain how we can really leverage API data from within a web app. And really the biggest feature that I want to talk about, if you go to this GitHub repo, you can see this O2 folder and O3 folder. The biggest feature I want to talk about is client-side routing, or this topic is also referred to as SPA. SPA standing for a single page application. But what does that really mean? What is a single page application? Well, if I go to Google and I search for something, like if I search for HTML, if I click on one of these links or one of the results in Google, right? If I click on this Wikipedia page, when I click on this link, it's actually taking me to an entirely different page, right? The browser has to completely repaint and re-render the entire screen. Let me go back. And so if I click on this link again, what I'm getting at here is that it's not like client-side JavaScript from google.com is injecting this Wikipedia content on the fly. That is not happening. This is just a traditional link, and when I click it for a few milliseconds, my screen goes completely blank, and it actually takes me to a new page. That's the default behavior of an A element or a link in the browser. On the other hand, a single page application that uses client-side routing, in a situation like that, when you click on a link, it doesn't actually reload the entire page. Instead, it uses client-side JavaScript to inject or update just the content that actually would change. I think the best way to explain this is just for me to show you a quick example. So right now, behind the scenes, I'm going to set up this folder called O2 Client Routing Plane. If you want to pause the video and set up this folder to follow along, you can. Essentially, inside this folder, you would just point your command line towards the folder and run npm install. Okay, and then you could just say node index.js, right? Just run this file with node. Okay, so behind the scenes, I just opened up that O2 client routing plane folder. In the terminal, I ran npm install, and then I just said node index to actually run that file. So now in my browser, if I visit localhost 3000, you can see this simple example I've set up for us. Now, I purposely made these buttons instead of links. In the real world, you wouldn't do that for accessibility reasons, but I made them buttons just to really illustrate the point here. So you could imagine if this instead was just a traditional blue link, when you click it, it's going to take you to an entirely separate page. However, if I click this About Page button, notice this content changes, and yes, the address in the URL bar changed. However, it really didn't reload the entire page. So again, if I click on contact, the same thing happens. And I can use my browser's backwards and forwards buttons. So this is behaving just like a traditional website that actually loads completely separate pages, but that's not what's going on. Instead, I'm using front-end or client-side JavaScript to change not only the content, but also change the address bar at just the right moments. Let me show you the code. Again, we're not going to write this together, but we can go through it really quickly together. So if we look at our index.js file, essentially I've made the public folder available, and then I'm saying for GET request, and the URL pattern is just a star, meaning for all GET requests. Doesn't matter what the address is, I just want you to serve up index.html. So that's pretty interesting. Even if I manually go up into the address bar and push enter and just visit /contact, it still loads the correct content here. So let's look at how that's happening. If we go into our public folder, you'll see there's a file named frontend.js. Let's look at that. So with client-side JavaScript, I'm looking at the path of the URL when the page first loads, and then I'm calling different functions depending on that value. Okay, and then if someone clicks on one of those 3 buttons, I'm just responding to that click event, and I'm using the browser's built-in history.pushState. Okay, and then finally I'm saying window.onPopState. So this is when someone uses their browser's back or forward buttons. I'm just looking at the value for the item that's in the history and then calling the appropriate function. And then those functions, all they're doing is just actually rendering the content. So as far as the end user is concerned, this looks and feels just like a regular website, but the performance is blazing fast. Right? The web browser doesn't actually have to re-render a new page from scratch. The whole screen never goes blank for a few milliseconds, and it doesn't have to make a full round-trip request for the entire page. Client-side JavaScript can do this for us, and this is what creates applications that feel super responsive, snappy, and immediate, almost like a real desktop application. Anyways, I would encourage you to dig through this client-side JavaScript code if you're interested in it. But essentially, now that we know how to do something like this, you can imagine that, for example, on the About page, what if we wanted to load data from an API when you display this About page content? So you could imagine we could make an asynchronous request to an API URL and then display that data here. In that case, you would really see how the front end and back end are working together. And that's exactly what I've set up for us in the folder O3 Client Routing React. So behind the scenes, I'm going to pause this video and go ahead and set up this folder. If you want to do the same thing, get this up and running, all you need to do is point your command line towards this folder, run npm install, and then we're going to run npm run dev. Let me set that up for you. Okay, so behind the scenes, I've opened up O3 Client Routing React. I just ran npm install, so be sure to do that. But then to actually get it up and running, instead of just saying node server.js, I actually want to use this command, npm run dev. I've set up a script called dev that will run both our Webpack front-end code and our server-side Express code. So just npm run dev. Okay. Now with that up and running, if I go back to localhost 3000, cool, so our amazing app. Now what I want to show you here, you can see I have these 3 navigation links. So if I click on Meowsalot, we see the name, the species, a photograph, and then obviously the same thing for barks a lot and purrs loud. Now if we go look at the code for this project, you'll see that the title, the text, the image, none of that lives in the animal component. Instead, it's being pulled from an API. Let me show you what I mean. So if we go into our front-end SRC, front-end source folder, and then you can see I've created a folder called components, and then we dig into the animal.js component. You can see I've written a bit of React code inside this use effect. So I'm using the Axios library. This is similar to performing a fetch request, but I'm hitting up /API/animals and then the particular name for this URL, right? So that could be meows a lot, barks a lot, purrs loud. And then obviously down in the JSX, I'm using that data, right? Animal.name, animal.species. So this is just sort of a big picture example of how the back end is serving up that data, right? From /API/animals, the raw JSON. And then our front end is not only using it, but our front end is also performing the client-side routing, right? Like, so for example, if I visit barks a lot, if I go up into the address bar, and even instead of clicking on one of these links, if I just actually go up into the address bar and push enter, right? Like if I visit this URL from a clean slate, it still takes me to the appropriate content. This is because I'm using a package called React Router. So my front end client-side JavaScript is handling the act of routing the different URLs. Let me show you how this works. So back in our server.js with our Express code, yes, I've set up different routes for the different animal API endpoints with the raw JSON. But if you scroll down, after that, I've said any GET request of any URL, just send back our static index.html, right? So our actual end users in the browser, they're not visiting directly /API/animals/barksalot. They're just visiting /animal/barksalot, right? So if you changed this to API/animals, that's the raw JSON, but the URL they're visiting looks like a website. So when they visit this URL, that's going to trigger this request, right? It's just going to serve up index.html. If we go look at that in the public folder, down at the bottom, that's just serving up our bundled client-side JavaScript. The source code for that lives in our front-end source, and it's just this overall app.js. And this is the real interesting part. So I'm using React, and to be more specific, I'm using the React router package. So if we scroll down a little bit, here you can see I'm using a switch, and I'm just listing out the different paths. Right, so I'm saying if the URL in the address bar matches this pattern, then show the animal component. And then I've also set up routes for the about page and home page, right? So in the footer, if I click on this About Us link, that shows the About Us component. I can click back to the home page, that shows the home component. I think it's a bit self-explanatory. Now, I realize the actual specific details of how React works and the React syntax and the React concepts, that's probably cloudy and confusing. I get that. This is not a 20-hour course on React. If you're interested in React Router, you can look up a YouTube guide or tutorial on it. Or I also have a premium Udemy course on React, but really that's not the point. The point that I want to show you right now is just how to get your back end and front end really working together. Because I think this is a fun exercise to practice leveraging your API endpoints. Now, at the end of the day, you could say, Brad, why would I set up all this client-side JavaScript? Why wouldn't I just actually have 3 different separate HTML files and just link them with traditional links? Why would I bother creating a single-page application? Well, that's a great question. I would say you don't always need to use client-side JavaScript. You don't always need a single-page application. However, it's an incredibly popular and in-demand skill set and topic, so I definitely wanted to run it by you in this video. Big picture, there's no one right or wrong way to build a website, but this is an important skill set to have. Anyways, I encourage you to experiment and dig through the code in this GitHub repo, but that is going to bring the technical aspect of this video to a close. Congrats on making it to the end of this video. Before we move on and talk about where we go next from here, while we're still on the topic of single-page applications, I just want to address the common question you might have. You might be wondering, Brad, is it really a good idea to have the raw HTML of our page be empty and let client-side JavaScript populate the content? Right, that makes sense for certain applications, but for other types of websites, in terms of accessibility and search engine optimization, wouldn't that be a bad idea? And the answer is yes. Depending on the site and your specific needs, that could be a horrible idea. So every project's different, but if you do really want to maximize your accessibility and SEO, I recommend checking out Gatsby or Next.js. So Gatsby is great, but ultimately it is just really a static site generator, meaning if you can get away with statically generated pages, that's fine. If, however, your site revolves around a lot of user-generated content that you can't predict when it's going to be coming in and what it's going to contain, and you want that to be optimally delivered for search engines, then I recommend Next.js. But really that's getting into a tangent. Right now you don't need to use Gatsby or Next.js. That was just in case you had accessibility or SEO concerns. Big picture, you don't need to get obsessed with client-side routing and single-page applications. They're just really popular right now, so I'm sure you'll want to experiment with them. Anyways, now let's talk about where we go from here. Now that we have a general idea of how the back end and front end work together, I think the next logical step is to actually push one of these holistic projects up onto the web, right? So instead of just localhost 3000, what if we want a real URL that we could share with our friends and family? Now, earlier in this series, we already learned how to push a basic static HTML site up onto the web, right? We used GitHub Pages. You could also use something like Netlify. However, when you want to push your own custom backend powered by Node, right, something like Express, you do need to use a different service. GitHub Pages and Netlify do not support that. So instead, in our very next video, we're going to learn how to use the service called Heroku to push an Express backend up onto the web, and it's not even going to cost us a single penny. As always, if you're enjoying this series so far, I'd appreciate it if you could share the link with your friends and family. Take care, and I'll see you in the next one.